Okay. First one. Okay. Good evening, everyone. And as a first new effort, we are going to start this class and this YouTube live streaming. Actually, I am using my webcam as well as my mobile cam. I am not accessible to WhatsApp at present. Okay. Please listen to this class carefully. And if you have any doubts, post it in live chat. We'll discuss this later. Otherwise, you can WhatsApp group also. After the end of the class, I'll conclude, consolidate the questions, and we'll discuss finally. Hope that this will work out for some time. Unless it is we are interpreted by the internet connection. My geo connection is working well. Okay, at present I see that in YouTube streaming that uh, network. So yeah, network is good. The excellent connection that they have mentioned here is it is in the streaming software. It mentions an excellent connection. Okay, I hope we'll start this class now onwards. Okay, so we are discussing about the AC fundamentals and since the last class. Okay, we are discussing about the AC fundamentals, and here in this class we are going to now we are going to discuss about what we studied earlier, and we want to add some more things to the to some more things here. Okay, so in case of AC fundamentals, we see that you can see the screen now. That what are the things we'll have a brief recap of what we discussed. And some of you asked some questions in the last class. See the questions, the answers for those questions, and now, and then we'll go to the impedance and power. This is what we are going to discuss now. Okay, so we know that an AC is something in which the voltage or current is alternating in nature, and this is characterized by various elements like frequency, time period, amplitude, instantaneous voltage, average value, and peak to peak value, and this is what we studied. And we studied some examples here that are always the instantaneous value is given by V of t is equal to Vm sine omega t, where Vm is the amplitude and omega is the angular frequency, and the time period t is given by 2 pi by omega. So this is the time period 0 to 2 pi is equal to 0 to t, and so omega t is equal to 0 to is equal to 2 pi, and so pi by omega. And we had an introduction to AC now. So we have two voltages here like this, Vm sin omega t and V1 of t and V2 of t, and this is what we studied here. And V1 of t is represented by Vm sin omega t, and V2 of t is represented by Vm sin omega t plus phi. And this angular differences you call it as the phase angle. This is phi, you call it as the phase. And this angular differences, that is, this starts at 0 and this starts as phi. And this angular difference, you call it as the phi difference. That is, the phase angle differences between the two, we call it as the phase difference. And this is what we have studied in the last class. And so we studied that average value. What is an average value of an AC? If you take a full sine wave, is always take one half cycle, you can find the average value, and then you can find we discussed about the average value also. So after studying the average, we discussed about the RMS value, which is given by 1 by root 2 times of the voltage magnitude. We studied the two important factors, and I said there are three factors, and we studied the two factors now, form factor and peak factor. Factor is form factor, which we are going to discuss today. And form factor is equal to RMS value by average value, which is 1.11 for a typical sine wave, and peak factor is maximum value by average value, which is 1.414 for a sine wave. These are the things we have studied earlier. And this is phasor, how to represent in a phasor diagram. So any sine, you can represent in a sinusoidal wave structure or single line diagram, single phase. This phasor diagram best or simplest way of representing different types of sine waves. Okay, this is what we are studying now, and I want to give some clarifications here based on what we discussed in this class. Okay, last class. some of you wanted me to discuss, want me to show this page again the end of the class, and this is what we studied. Okay, the phase of an alternating current or voltage may be expressed in terms of time, measured in terms of seconds or fraction of a time, or the angle expressed in terms of degree or in radians. Okay, either in terms of or 90 degrees or 45 degrees, and this is what you call it as a phase. And if two alternating currents or voltages act simultaneously in the same current, okay, and do so in such a manner that the peak values do not occur at the same time, then we say that there is a phase difference between the two things. That is, one reaches the peak value at 90 degrees, if another reaches the peak value at 180 degrees, that both has a phase difference of 180 minus 90, 90 degrees. So the two positive peak values of voltage and current has a phase difference. And this is what we have studied here. Now let me explain this waveform that in you're using a board now. Okay, just you keep noting, keep watching this one. Okay, okay. Please wait a moment so that I can move it to it onto my mobile camera. Okay, okay now. Okay, now you can watch the board that there are two waves here. There are two waves here. This one sine wave, and there is another sine wave here. Cos 90 axis. This starts at 0. This equal it as, and this call it as the, let's call it as one of even of t. So as it is shown in the PowerPoint earlier, you can see that there are these are the two waveforms. So you can write that one of Dm sine of t of v1 of t, and v2 of t is omega plus, sorry. Okay, so that is, so you can see here that the v2 lags behind v by an angle of 90 degrees. Lags behind by an angle of 90 degrees. How to represent these two waveforms in a phasor diagram? You see here representing angular difference, angular difference. The two phases are now 90 degrees. That is V2 lags behind V1 by an angle of lags behind V1 by an angle of 90. Suppose if I have two waveforms like this, is represented by the equation two waveforms. So when I say that T1 is one of t by Dm or t by 1, see that another v by sine phi 2. See that phi 1 is the phase of this one and phi 2 is the phase angle of v2, and this difference, that is phi 1 phi 2, call it as the phase. Okay, and this can be represented graphically. So imagine a reference v1 by represent v2. v2 is represented by like this line. This is how we can represent two different graphical ways for simple. doing performing calculations. Okay. So with this idea behind, we are going to concentrate on some more topics related to this. Okay. Now we'll go to the PowerPoint slide again. We are moving to the PowerPoint slide again. So here you see that A and B are here. So B is lagging behind A, and which is represented. Of course, they are taking a different angle. Now I have touched. You can follow what I have drawn in the board. Okay. Now you know what is phase and a phase difference. So phase, as I said, is measured in terms of time, time in terms of seconds, or it may be in terms of angle expressed in degree or in minutes. So the phase difference is between the phase angle difference between the two phase. Okay, this is what we study now. Now we are going for a simple AC resistor circuit. A simple AC resistor. This circuit has a sinusoidal voltage curve. Okay, sinusoidal on AC input, AC voltage input, and there is a resistance. So we know that in a resistance, the voltage and the current are in phase. So that is the voltage. There is no lapses. That is no lagging or leading of voltage and current between them. Okay. So there is no. So the voltage and current will be always in phase. So I have a circuit like this. So here that there is an sine wave. Okay. So here I see there is a resistance. So when I see that this is B of T and this is R and this is R, now I can say that there is a current of I that flows I. When I draw a voltage and current waveform, this also this is so the voltage and the current starts at the same, okay, reaches the mix maximum at the same time. Also it reaches negative maximum at the same time, and it completes one cycle at the same time period. That is, there is no phase difference. There is no phase difference between the voltage and the current. And so I always say that the voltage always say that the current and the voltage are in phase in a pure resistive circuit. Okay. Now coming to an inductive circuit. I replace this resistor with an inductor. I replace this, and now how it is going to be? So we know that so we know that the inductor by its nature it opposes any change in the current, and so always inductor lags current in inductor lags the voltage by an of but this I and this is your V. How do I represent it in a phasor diagram? So this is the C, and then the current lags by an of P and I are represented in a phasor diagram like this. P and I, that is I lags behind the voltage, an angle of 90 degrees. Okay. Now we are going to replace the inductor with the capacitor. The capacitor. Okay. So the capacitor. So what about the nature of the voltage and current? I will take that capacitor opposes any immediate change, and so always. So we are clear that the capacitor in a capacitor, the voltage always lags behind the current. So let's say that this current waveform, and there is going to be a voltage. So capacitor voltage current reaches 90 degrees ahead of voltage. Okay. How we are going to represent? Here we see that the voltage leads the current leads voltage. Hence, I'm going to mention current. That is the current leads. Okay. So this is the current. Current represents this way. So coming to the conclusion of these, this understanding how the phasor represents. So under that is H, which is current, this is the O or this and I. The case. Coming to the inductance. So here is the O. And then here the current lags. This is the coming to the capacitance. Okay. Capacitor. Here is the voltage. And here we see that current leads the voltage of 9. So here is the this is the pure resistance, inductance, and a capacitance. Okay? Pure resistance, inductance, and a capacitance circuit. Now, coming to the case of combination of a resistance and a because most of the applications have a combination of resistance, capacitance, resistance, capacitance, and the inductance. Okay. So always a circuit is combination of all the at least any two parameters. So here I have a resistance R, here I have an inductance of L. Now the current I. So now this is the current I. So we know that in a resistor, the voltage and current are in a resistor, take the voltage and current are in on the cylinder. That is, the current is always lagging behind the voltage. And now coming to this, how do you represent? Here is the voltage. So instead of keeping exact 90 degrees, so here because of the influence of this the current, the current lags an angle of current lags behind of okay lags. It is not exactly 90 degrees. It is somewhere between 0 degree because we know that the angle between voltage and current in a resistor 0 and the angle between voltage and current in a is so because of the combination of R and L, this angle phi is somewhere between 0 and imagine if R is very high, if R tends to infinity, then this curve will move from value of R, value of R, value of when R is in this phi tends and similarly when L is in L that is connected, this phi tends to become so the angle depends upon the nature of if the resistance is very high and dominating the phase angle is almost very closer to it. And if resistance is very less and inductive circuit is dominated by the inductance, then this phase angle is almost very closer to this 90 degrees. Okay, that is the circuit is more inductive than resistive in that case. Okay, now we are going to replace this inductance with a capacitor. A capacitor. This is what about this? This is an RC circuit. Okay, what about the nature of our RC circuit? Of voltage and current in an RC. So we can say that. So that is so in a resistor and I are in phase. I or in this represents. Means in an inductor, this V and I are drawn like this. I leads the voltage by an angle of 90 degrees. So what about the case now here? So this is not true here. Okay, this is not the case. It's a capacitance. So the current is somewhere. So what is this? This angle is phi. The angular difference between is difference between V and I. Again, we see that when the circuit is more capacitive, this is much higher. That is, the I circuit is more resisting. This I tend the angle difference. It depends on the phase angle. That is the phase difference of R and R, the value of R and C. So this is a very important concept. So even RC and similarly in an RL circuit, this is the nature of an I. So these things you have to keep in your mind for calculation. Okay, okay, for any other calculation. So okay, now coming back to the slides. Okay, we go back to the slides and you look at the slides for some time. Some of the other important concepts before we go to the um, um, board again. Okay, for another derivations and calculations. Okay, so this is the concept you have to keep it in mind. Okay, resistance, reactance, impedance, and inductance. Okay, okay, inductance we have already studied it. What is resistance? We know that. What is reactance? Again, we studied when we discussed about it in inductive when about inductance and capacitance separately in the earlier classes. Also, resistance is the unit in ohms and is the, okay, and reactance is the ohmic term of a inductance and capacitance. And reactance has two parts, that is two types. One is inductive reactance, other one is the capacitive reactance. And inductive reactance we know that is given by 2 pi fl, that is 2 pi f is omega, so xl is equal to omega l, and it is the ohmic term of the inductance. And xc you call it as 1 by 2 pi fc or 1 by omega c or c omega, which is a ohmic term of the capacitance. Okay, ohmic term of the capacitance. And so this is another case. And what about the impedance? Impedance is a combination of the resistance and inductance. Z is equal to R square plus J X square. Okay, okay, now um, coming to this, okay, this is the combinations. Okay, now we know what is an impedance. Impedance is a combination of these three parameters. Now go to this book, you take a problem now. Okay, now we are going to take a small problem here. Okay, this is the problem we are going to study now. So this is the problem we are going to say now. So what is this? So here there is a circuit here. I'll draw it later as a resistance and a capacitance in combinations. So you have to draw the impedance and you are going to find the voltage and the current. Voltage and the current. Okay, now we'll go back to the board and we'll do some work out some problems or something related to this impedance analysis. Okay. Okay, now let us have this. So we know we have just studied that Z is equal to R plus J or plus J, or we can say that Z is equal to square root of R square plus X, R square plus X square. So for example, when I have a circuit like this, a resistance, here there is a resistance, here there is a resistance. You have to divide this circuit in. You have to call this as an Z1. You can call this as Z2. And you can call this these two, call it as Z3. So we can call here is that 1 is equal to R plus J0 plus J0, where Z is that since there is no inductance or capacitance, they come to is that 2 is R plus J, let's say R1 plus J, yeah, J R into J, R plus J into K. Coming to 3, you can R 1 plus 1 by J into C is the capacitance. Okay, so this can be otherwise written 2, sorry, 2 minus J by up to divided by 2 minus J by omega C. So this is the thing. So Z1, Z2 and Z. In DC circuits, we know that if there are Z R1, R2, R3. In DC circuits, we see this is R1, R2, R3 are replaced by Z. So we know that Z2 and Z3 are in parallel. So if we want to simplify circuit Z equivalent can Z1 plus Z2 parallel Z. So you have to simplify these two elements and you have to think this is the case. Now coming to our problem. Okay. Coming to our problem. So here is the sum. What it says. So I have a voltage source here which supplies a resistance and a capacitance. And this, so B, yes, this is R, this is C. And this Vs is given by 10 cos 40, 10 cos 40, and R is given by 5 ohms. What is mentioned here? The capacitance is 0.1 farad. And the capacitance is 0.1 farad. Okay. Now coming to this. So we have to form the impedance. Impedance is that can be given as R plus J C, which can be given as R plus 1 by J omega C, which can be written as 5 plus 1 by J. So you know that omega is equal to 4. Omega is equal to 4. So 4 into, and the capacitance value is 0.1. So 0.1. So this equal to Z is equal to 4. Sorry. 4 is 5, 5 minus J divided by 4 into 0.4 divided to 0.1, which can be further minus 2.5, 5 minus 2.5 J. So that Z is of ohm. Z is represented in terms of ohms. Now to find the current I. So that is I is by Z. So V is equal to N, P is equal to N, and it's 0 because here, okay, and Z is equal to 5 minus J. Now you take complex conjugate. So multiply numerator and denominator conjugate, divide it, you'll get an answer that 1.8, 0.8. Okay. So here you see that 1.7 and angle 6.6 for I. So that is the current in this circuit is given by this. So we know that I in rectangular form is I in the form. Okay, I in the rectangular form is this, and I in the polar form to be. Now, what else is asked? We have to find out the voltage across the capacitor. Yeah. So we have to find voltage. The voltage across the capacitor is given by I is equal to, so V is equal to I in, so we know that what is I. Okay, we know that what is I. I is equal to 1.79 and 6 is, so that is divided by, yeah, ZC we know that 1 by omega C, yeah, which is, can be represented by J 4 in 0.1, which gives you 4.47 angle minus 6 minus 60 degrees. Okay. This is a simple problem how to solve an AC of using. Okay. So we know that from this we understand that all the values Z, whether it is Z or voltage or current, or always in terms of complex. They are always in terms of complex. Because Z is equal to R plus J in. And we know that Z is equal to R square plus hmm. So how do you represent this? And represent R this, huh? Okay, this is R X. Take this sign as plus phi. So when you say that it is sin phi, like cos phi, how it does, right? And tan phi, right? So this cos phi, that is our power factor, is a factor load in which an AC circuit is. The power factor is this phi and phi is the phase differences, again represent phase difference P and I system in a power AC system. Okay. So the angle between can also be calculated. Cosine of the cos inverse of R by L. So cosine of the angle between B and I equal. But in fact, but in fact, small disturbance now. That's a small disturbance now. Okay. Okay, now you can see the screen. Okay, in full. Okay. So I kept my mobile in. So I got some WhatsApp call. But in WhatsApp call now. Okay. Okay, now so we know that what's the power factor now. So we know that we see that cos phi, we call it as the power factor. When I say that this is R, X, and this is Z, and phi, cos phi is represented by R by, otherwise cos phi is the phase difference between and between V and I. So these things you have to keep it in your mind when we are going for solving the problem. Okay, when we go for solving the problem. Okay, coming to this, we'll go to the next topic. Okay, now we'll discuss about the next topic. So what we studied before going to the next topic, what we studied now is how it works between how that is the AC behaves in an pure resistance, pure capacitance, pure inductive circuit, and how the voltage and current behaves in a pure in an R and C combination or an L combinations, and we had the three important elements, that is resistance, reactance, and then impedance is equal to R plus jx. Okay, where x is equal to omega L bar for an inductive circuit, and x is equal to 1 by omega c for a capacitive circuit. And these are the things we studied, and we did a problem to solve how to solve a problem, how using a simple AC circuit, how to solve it. I mean, yeah, சரியா? So the same way வந்து பார்த்தா we have to same way we have to what we have to do is the simplify circuit simplifications நம்ம அப்படியே நம்ம பண்ணிடலாம். So you can do the simplifications like the same way. Okay, now you see the board. Now you watch the board here. So let me give a circuit like, okay, here is a circuit with too many impedances like this. Yes. This is Z1, Z2, Z3, and Z4. There are too many impedances here like this. So we know that Z3 and Z4 are in series. So I can say that Z34 is equal to Z3 plus Z4. Okay. Okay. Sorry. Okay. Now we got it. So here you see that Z3 and Z4 are in series. Z3 and Z4 are in series. Okay. So Z34 equivalent, you can call it as Z3 plus Z4. Now you can simply modify this circuit like this. That is Z3. This is Z34. Okay, this is Z34. And now you can see that Z2 and Z34 are in parallel. So I can say that Z2, 3, 4 can be given as Z2 parallel Z3. Okay. So now this circuit is further simplified as Z2. And now you can find the total impedance can be Z1 plus Z23, Z234. So Z equivalent is equal to Z1 plus 4. So that is the final answer. Suppose if V is given means V of t is given here means, then you can find that I is equal by, so is the total current. Is the total current that comes out of this, right? Right. And so when you want to go back to the original circuit, and if this, yeah, once you found the total current, you have to go back to the original circuit and you have to find the values of voltage, current that flows through each and every element connected in the circuit. Yeah, this is my Z2. This I gets divided into I2 So how do you find this? Again, apply the same circuit, that is current division principle, what we have already studied in these circuits, and get it. What is the current division rule? So I1 of I1 can be given as Z total. Z total. Yeah. Sorry. Z34 divided by Z2 plus Z3. This is the concept. This is the concept. Okay. And similarly, you can find once you know the values of I1, you can, yeah, this is, you can find the value of I1. So that I is equal to plus, yeah. So apply calculation rule, find the values of I1 and I3, and then once I2 is found, you can find the I3. This is the, and also the same voltage and the same current division principles are applied AC circuit as well as in the as it is used in the okay. So these things you have to keep in your mind while solving the problems. Okay. Same concept that, for example, when the two resistors are contained in parallel, R1 parallel, here it is going to be Z1 parallel Z2. So always all those elements, that is all those elements are represented here in terms of complex terms. Okay, are represented in terms of complex terms. That's all. So அங்க நம்ம பார்க்கும்போது there is no complex term, only resistance வருது. So இங்க நம்ம பார்க்கும்போது resistance reactance இருக்கு. Always when you go for um, circuit reduction techniques, when you go to solve for voltage and current, everywhere this is the case. Okay, everywhere this is the case. That's all. Now, okay. So let me go to the slides. And we have some more discussions with respect to power. Okay. Okay. Coming to the slides. Now we are going for the AC power. So here we see that Z is equal to R plus JX. So there are two. That is the power is not the same as it we have studied in the DC circuits. Here we see there are three types of power. So one is denoted by S. You call it as an apparent power. One is denoted by S. You call it as an apparent power. Other one you call it as the real power, which is here mentioned as P. The third one you call it as the reactive power. In AC circuit, in an AC circuit, we have three types of powers. We study three types of powers. One is real power or active power. Other one you call it as the reactive power. And the sum of the two you call it as the apparent power. Okay, so the real power you have to mention in terms of, okay, the real power is mentioned in terms of volt ampere. It's a product of voltage and it's a product of voltage and current. Okay, the product of voltage and current. Let's go back to this one. Okay, let's go back to the board again. Let's go back to the board. Now the board is ready. Okay. Um, okay. Now see here. So we see that yes, equal to P plus J into Q. So P equal it as the real power, this equal it as the reactive power, and this equal it as the apparent power. Apparent power. This equal is it in terms of volt ampere. This is measured in terms of watts. This is in terms of watts. So that is unit for real power is or active power is watts. Unit for this, that is reactive power. Reactive power is watt. Apparent power is mentioned in terms of the volt. Okay. So in a DC circuit, DC P is square or otherwise can be. So that is the power that is actually consumed by the resistance, you call our power that is dissipated in the resistance of the load, you call it as the you call it as the you call it as the real power or active power. Okay, so that again, when you come to the reactive power is something that is exchange between the exchange between reactive components. So that is the reactive power is influenced by the presence of the inductors and capacitors in the circuit. Okay, so the reactive power is again it's meant Q can be V square squared by V squared by X, and we know that this is mentioned in watts. This is mentioned of var, not VAR, it is VAR, that is volt ampere reactive, volt ampere reactive. Okay, volt ampere reactive. Okay, now, what about this? So this is also a complex term you see here. So S is equal to P plus JQ is also going to be a complex term. You know that P is equal to this is because of the power dissipation in the resistance, and Q is influenced by the presence of inductance and capacitance in the circuit. Okay, is influenced by the presence of inductance and capacitance. By nature, inductance is the reactive power consumer in our electrical circuit, and capacitance is a reactive power supply, delivers reactive power to the circuit. Okay, so it delivers reactive power in the circuit. So here again, the bigger is the complex because it's a complex. This can be otherwise represented in a triangular form. This is your watt component in terms of watt. Here is my watt component in terms of watt watt. This is where yes in terms of volt ampere. This phi is the power factor. Phi is again we see that is the angular difference between voltage and current. Otherwise we know that cos phi is right. Okay, and phi that is this power factor angle is divided by the load that is connected to the system. Decided by the load that is the AC connected to the AC system. Okay, so that's it. So again, power factor angle can power factor cos phi can be given as so that is listen side by height by P. Then we have another formula cos phi is equal to right cos phi is equal to P by S. Okay. So what is a real power and what is a reactive power? Okay. Now we go back to the slides. Okay. So what is the real and the reactive power? And the definitions we studied it. Yeah. We studied the definitions. Okay. Now you see here. Okay, definitions. I explain the definitions. These are the definitions we studied here. Okay. The real value of real power on the active power is the power that is dissipated in the resistance of the load. So and P is equal to I square R V square by R, and Q is equal to I square X and this. And then the apparent power is the power that appears to be flowed to the load. That is what a generator in the pattern, that is the power that is given to the load. That is the power that is flowed to the load. And S is equal to V into I, that is the voltage into current, that is I square Z or V square by Z. You call it as the apparent power, and it is measured in terms of volt ampere. This is measured in terms of volt. This is the relationship between apparent power, real power, and reactive power. Apparent power, real power, and the reactive power. And this is the power triangle. Just now I have drawn it on the board. Okay, this is the power triangle. We know that S is equal to I into V, and P is equal to S into cos theta, that is apparent power into cos theta, and then Q is equal to apparent power into sin theta. This is what we studied here. We had to work out some problem. We'll discuss the problems in the next case. Okay, what is the difference between, what do you mean by real power and the apparent power? Apparent power, real power, and reactive power. So let me give you an example. Okay, this is, so always in the path, this is the watts. Okay, so this is the actual power that is consumed in the load for an effect. Okay, and this is something that supplies the inductance of a supply. For example, if you have a huge inductor motor, have a compressor, if you have a big motor compressor, air conditioner, or that is air conditioner or refrigerator, in which inductance is dominating, and this Q is that to supply the reactive power of the inductance, and this P is used to convert, that is convert the free electrical energy into into that is converting electrical energy effective application. Okay, both are essential, but we need to be very careful that this component should not be much higher. Okay, for example, how to differentiate between a real point. Let me give an example. Suppose if you are going to take a lunch where your mom has prepared a sambar, right? White rice and sambar or kolambu for your lunch. Okay, so in sambar, your mom used to add tomatoes, brinjal, and then turnips and a few more vegetables with some curry leaves, coriander leaves. All those things will be added along with some grains to prepare the sambar. And now, while taking the meal, and you used to, most of us used to take that tomato and that unwanted vegetables, and we keep it aside, and then we'll consume the remaining portions. And those tomatoes and other unwanted, that is உங்களுக்கு பிடிக்காத மற்ற காய்கறிகள் இல்லையா, மற்ற காய்கள் எல்லாமே என்ன பண்றீங்க, you are going to keep it aside, you're not going to take it down. Okay, it doesn't mean that they are going to be wasted. They are not waste. Okay, so for example என்ன பண்றோம் அப்படின்னு கேட்டீங்கன்னா, இந்த காயெல்லாம் இப்ப சாம்பார்ல வந்து உனக்கு தக்காளி பிடிக்கல, அதுக்கான தக்காளி இல்லாம சாம்பார் வைக்க முடியுமா? No, it is not possible. கத்திரிக்காய் இல்லாம சாம்பார் வைக்கலாம் நினைக்கலாமா? It is not possible. So few vegetables போட்டாதான் சாம்பார் பண்ண முடியும். ஏன் அதெல்லாம் ஒதுக்கி வச்சுதான் சாப்பிடுறீங்க. அப்ப வந்து என்னன்னு கேட்டீங்கன்னா, அந்த இது இல்லாம சாம்பார் பண்ண முடியாது, பட் அதெல்லாம் அவசியம். ஆனா அது உனக்கு சாப்பிடவும் பிடிக்கல, that you call it as the reactive power. So the remaining portion of the sambar, what you are actually consuming, that's an example for real power. சரியா? So another example I give you, that is if you're taking வெண்பொங்கல் வந்து பார்த்தீங்கன்னா, so mothers used to add spices போடுவாங்க, மிளகு எல்லாம் போடுவாங்க இல்லையா? சாப்பிடும்போது மிளகு சாப்பிட்டீங்கன்னா உங்களுக்கு இந்த மாதிரி காரமா இருக்கும், and most of you won't like it இல்லையா? அப்ப என்ன செய்வீங்க, அந்த மிளகெல்லாம் some of the people சின்ன சின்ன பிள்ளைங்க என்ன செய்வீங்க, used to collect all those மிளகுஸ் and you keep it, பெப்பர் எல்லாம் கலெக்ட் பண்ணி சைட்ல வச்சிட்டு என்ன பண்ணி used to consume that பொங்கல் இல்லையா? அந்த பொங்கலை கன்சியூம் பண்ணுவீங்க. ஸோ அதுக்காக மிளகு இல்லாம without pepper can you prepare a பொங்கல்? No, it is not possible. சரியா? For preparation of பொங்கல் you need to add some pepper. இல்லையா? பெப்பர் போட்டு தான் பண்ணணும், அந்த பெப்பர் போடணும், அதே பெப்பர் போட்டு தான் பண்ணணும். அப்ப என்ன பண்ணணும், pepper is essential for preparing pongal, but you don't like it, so that pepper, what you are going to take it, along with that pepper some portion of rice is also going as a waste, and that you call it as the reactive power. The remaining portion of pongal along with sambar and chutney you are going to consume it, that is the active power. And you know that some of the people என்ன பார்த்தா, they have a good habit. என்ன பண்ணுவாங்க, they consume சாம்பார்ல இருக்க எல்லா வெஜிடபிள்ஸ் என்ன பண்ணா வீட்டுல சாப்பிடுவாங்க. That's a good habit. In that case you see that the power factor is zero, is the reactive power is zero. Some of the people என்ன பண்ணா, they consume on the pepper along with the pongal. In that case the power factor in that case the reactive power is going to be zero, that is the power factor is going to be 1. So that is the best example for an improved power factor. Okay, so let me give you an example in non-veg also. என்ன பண்ணீங்க, if you want to take a chicken leg piece, you cannot consume a leg piece without a bone. For consuming a leg piece, you have to pay for the bone also, flesh as well as for the bone. It doesn't mean that, it doesn't mean that you have to consume the bone. It doesn't mean that the owner of the restaurant is going to ask you to pay only for the flesh. So when if you want to take a leg piece, you have to pay for the flesh as well as for the bone. So paying for the bone is what you call it as the reactive power, and consuming the flux is what you call as the active power. So with that examples we'll conclude now. Okay, and we'll complete and conclude now. Let me, okay, let me have the video now, and if you want, you can continue with us. Okay, so this is the case. Okay, but what we studied till now is we studied about the nature of voltage and current in an C, in a resistance, inductance, and capacitance, a combination of RC, RL today, and we know what is an impedance, and we know how to find a power factor angle. We know how to reduce a circuit using an impedance, a circuit using a circuit with different impedances kind of in series and parallel combination. எப்படி circuit reduction technique can be applied பார்த்தோம் இல்லையா. அதுக்கப்புறம் we studied what is the power in an AC circuit நம்ம பார்த்தோம். We studied there are three types of power: real power, reactive power, and then apparent power. And apparent power is the sum of all the three powers ன்னு சொல்லி பார்த்தோம் இல்லையா. apparent power is the sum of all the three powers அப்படின்னு பார்த்தீங்க. So with this we'll stop here. Next classல வந்து we'll work out some problems. I'll give some problems next class நம்ம பார்த்துட்டு, and then we'll go to the mesh and nodal analysis, and then and different theorems applied in an AC circuit. And this is what we are going to study in the next class. Now I want you to, okay, now we will stop here. So now I want you to open the quiz app. I want you to open the quiz app. So let me launch the quiz. Okay, you can see the quiz now here. You can see. Let me launch the quiz. Let me launch a quiz. You can open the quiz app. Okay, I hope that everybody has opened your quiz app. Let me launch a quiz on AC fundamentals. Here is the game code. Here is the game code. Join myquiz.com, and the game code is 617 617 948. They start entering it. So it's good that everybody is now adding up. Okay. 20, 20. The people have added. Come on, quick, quick. Use the code and start entering it. 25. Okay, good. So see here, 31, 32. So I will start once we reach another 4 or 5. Okay, 40 vandre start பண்ணிடுறேன். Be fast. Hmm? The quiz time is only for 10 minutes. Quiz time is only for 10 minutes. Okay. Okay. So let me start quiz. So we have 40 players now in a class of we have a class of 62. We don't know what about remaining 41. Okay, let me end the live streaming. Live streaming end பண்ணிடுறேன். But quiz will continue. Okay. லைவ் ஸ்ட்ரீமை நான் எண்ட் பண்ணிடுறேன். Quiz will continue. Okay. Quiz வந்து will be closed after 10 minutes.